Hey guys, welcome, and this is our 6.2 video. Let's begin. The only thing that we really need to write down is about the parallelogram. Now I can talk about the other things, but a parallelogram, it's a quadrilateral with both pairs of opposite sides are parallel. So this is a perfect picture right here of a parallelogram. So we're going to be talking about the properties of parallelograms. Opposite sides and opposite angles. So as you can see in this picture, the red bars here, AB and CD are opposite sides, AD and BC are opposite sides, and then opposite angles do not share any sides. So A right here, C and A are two opposite sides from one another. So we're going to be talking about opposite sides, opposite angles in the parallelogram. And we might even talk about what's called consecutive angles, which would be B and A are consecutive angles when they're right next to each other, or A and D would be consecutive. But really the only thing you need to write down is what a parallelogram is, and preferably this picture. Let's go ahead and talk about some of the properties of a parallelogram. Our first property is this. Again, if it's ever too hard to read, you can always go ahead and pull out your book and write it down. I would like you to write the words, and if you could, the picture as well. It can be a little bit more simplistic if you would like just putting this piece right here. Looking at this, as a quadrilateral is a parallelogram, then its opposite sides are congruent. So not only are opposite sides parallel, but they are also congruent. So they're congruent and parallel. I'm going to go through these quickly. You might have to pause them and write them down. Also, Theorem 6.4, if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. We talked about this earlier. Angle A and B are consecutive, so they add to 180. Same with A and D. If we look down here, A and D, they add to 180. So consecutive angles are always going to be supplementary. Then we have, if a quadrilateral is a parallelogram, then its opposite angles are congruent. So we can see A and C are congruent angles, B and D are congruent angles. So we have two things that have to do with angles. Opposites are congruent, consecutive add to 180. Okay? And you remember, I feel like this whole geometry class, we've either been setting things equal to each other or adding them to 180. So we're kind of still in that same boat, but we just got to make sure we understand the difference. Alright? And a lot of rules here. In a quadrilateral, if it's a parallelogram, then its diagonals bisect each other. Again, bisect means it's going to break into two congruent parts. Notice right here, AE is going to be congruent to EC because E is in the middle. Same BE and ED are congruent because E is in the middle. So again, we have quadrilateral. If it's a parallelogram, our diagonals are going to bisect each other. All these are going to help us create equations. Again, we're taking a picture and we want to create an equation from it. Our last one is not talking about a quadrilateral, or more specifically our parallelogram, but talking about having three or more parallel lines. And what we can do here is we have congruent segments. Okay, so if we take a look at these two lines are cut by three parallel lines. C, this area C and E are congruent. Same with this would be true. D, BD, and DF would also be congruent. So basically, as it says, if three or more parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. Okay, so we see one side congruent, the other side is going to be congruent as well. Let's go ahead and apply some of these problems. Okay, using consecutive angles is what we're looking at here. We see a picture here, and we have S is equal to 64 degrees. We want to find out what P is. Okay, so P is right here. Now P is not an opposite angle. If it's an opposite angle, we would pick B as our answer, but it's not. P and S are consecutive. That means they need to add to 180. And 64 plus this number, 116, should equal 180 degrees. Let's go ahead and double check our answer by clicking our solution. And we take a look. P plus S should equal to 180. That's because consecutive angles of a parallelogram are supplementary. We plug in the 64 that we know, and we solve, and we get 116. So the correct answer was what we've said, C. Alright, let's move on to get a couple more problems. Okay, this is probably one of our most difficult problems. Now, in general speaking, geometry, this is a very simple problem. If we take a look, we know that we have a parallelogram. We're given a parallelogram, so we know that the diagonals bisect, which means y plus 10 is going to be congruent to x plus 8. So we can go ahead and mark that real quick. So we know that this segment here is congruent to that segment, and then we can show that this segment x is congruent to y plus 2. Our problem is when we set up an equation, x equals y plus 2, we have two unknowns, which means we can't solve for one variable. And vice versa, in this one with the yellow, we have y plus 10 equals 2x minus 8. Two unknowns, we can't solve for it. So what we're going to have to do is use a system of linear equations to solve this. So we're going to have to go back into our algebra skills. So if you want, you can actually try this one, but we're going to go over it right now together. And I'm going to have the help of our little guy to help us out. So the diagonals of the parallelogram, they bisect each other, which we talked about. And so we can go ahead and write Kp is equal to Np, which is true. And then we can write Lp is equal to Np, which is true. Moving forward, we are going to set up a system of linear equations by substituting the algebraic expressions for each segment length. So we're going to just plug in our information, boom, 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 and now we're here. So we set these up equal to each other, but now we need to solve somehow for this. So we see that these are two equations, so we can substitute y plus 2 for x in the equation 1. So I can take this guy and I can plug it in to that right there. So that's what we're going to do. So I'm going to move it forward and we're going to continue on. So there it is. We get y plus 10 equals 2. Instead of that x, we plugged in y plus 2. We're going to carry out our algebra. So we're just going to carry out the algebra. The 2 right here, 2 times 2 is 4, so we got 2y minus 8. Okay, we can go ahead and combine like terms there. Right here, we can go ahead and subtract y from both sides. This gives me y minus 4. Then we can go ahead and add 4 to both sides, and that leaves us with y equals 14. Once we know y, we can plug it back in to our next equation. So we can substitute 14 for y in equation 2 and solve for x. This one's going to be much simpler for us. So take the y out of this equation here and hit play to continue. Boom. And so we get 14 in there for y, add them together, and we get 16. And that's what our x value equals. So we have our two values of x and y, but we wanted to find km and ln. So what we need to do is go ahead and substitute that in. So km is the entire segment, so we're just going to double up kp. And we know what y is, so we're going to plug y in as 14. And then we can add that 10 to it to create 24. If we add those two together. And then multiply by 2 and get 48. So km is 48, and then ln, we want to find that whole segment. And so we're going to do the same thing. We're going to go ahead and notice that LP and PN, we could just double LP, which is just x. This one's easy. And x is just congruent to 14, so we just do 2 times, 16, wrong number. 2 times 16, and we get our answer of 32. So those are our two final answers, 48 and 32. So a little bit more work, basic concept, we just set them equal to each other because they bisect, but a little bit more work. Last one, this one's a little bit faster, and we'll end our video. Alright, let's see here. We got a lot going on. So take a look. We got two transversals. All of these are parallel. So AE, BF, CD, DH, CG. These are all parallels. And it says AB, BC, CD are all equal. So these are all congruent segments, and they're all equal to 2. So as we carry this out, we see all those parallel lines. We see that these are all segment 2 in length. And then we know EF is 2.25. What is EH, which is this whole segment? So we can go ahead and we know that if these are all congruent segments, these are going to be congruent as well. So we can actually plug all those in also as 2.25. So they're all congruent. So we're basically just doing 2.25 plus 2.25 plus 2.25, which we're going to show you right now is the case. So using segment addition postulate, EH, we're going to add them all together and substitute in 2.25, and we get 6.75, and that is it. Alright guys, thanks for watching. I'll see you later.